Here we have a Gigabyte 3080Ti OC12GB video card that came in for no power. We have it right here, and let's read what the customer wrote. The customer wrote, I think a VRM chip was fried by liquid getting spilled into the top of my tower. As far as I could see, that is the only damage on the card. So the customer was able to tell that there was damage on one or more of the VRM chips. How is that possible? If you look from the top here, I mean, unless you have Superman eyes, maybe that would be possible, but otherwise, if you do not open the card and look at the card, you're not going to be able to see it. It tells me the customer did open the card to look inside. I did not ask Big Boss if the seal was broken or anything like that, but it doesn't matter. The card was mailed over for repair, and that's what we're going to do, as long as it's practically fixable. So let's take a look at VCore. I do see signs of liquid here, but that may be nothing. My question is, how did the customer know that we have a problem with one of those chips? Unless oh, look at this. Yeah, look at this. There's no way to tell from the top. If you look from the top, there's no way to tell if any one of those chips are damaged. I see signs of damage here and also here. I see a solder blob sticking out. You know what? Why not do a full visual inspection? Since liquid was spilled, we need to inspect the whole board. Start from the top here, and in the meantime, while at it, let's inspect our 12-volt lines. Meter in diode mode. And start by inspecting right here. We have 0.47, that's very good. And if we inspect here, oh, we have a partial short. I mean, of course, if we have problems here, then it's going to show up here. I've done countless number of videos where we had a short circuit on the 12-volt line. That was a result of a bad DR MOSFET, and I see two bad ones here. But it's not showing a full short, but a partial short, 0.01 voltage drop. If we go to resistance mode and we measure, then we have 100 ohms. If we measure here, we have around 470 ohms and not 100. So this is not showing a zero, but it's showing a partial short. What about the fuse? If we measure here, we have 8.8K. And if we measure here, 112 ohms. So we have a blown fuse. If we go to diode mode and we measure, we're not getting a beep. So the fuse is blown for this guy. And if we check here, we do have a beep. We check here, we do not have a beep. So nothing on this side of the board. What I want to quickly do is measure the PCIe 12 volts, 3.3 volts, measure 1.8, and measure PAX. While at it, meter in diode mode, if we measure here, 0.49, 0.449, and if we go to resistance mode and we measure our 1.8 volt line, we should have something like 227 ohms, and we have 213, and we should have between 4 to 9 ohms here on packs, and we have 7. Flip the board. This board is glossy, so you're gonna see some reflections. I do not see signs of liquid damage anywhere on the board, except for those two DR MOSFETs. Our data lines, they look good. And we see residue of soup here. I do not know what type of soup the customer was having. Or if the customer is Indian, maybe he was having biryani. And the fuse back here, 0 ohms, meter in diode mode, and we should get a beep. All right, the card is good. The card looks visually good. Let's go back here. We're gonna replace both DR MOSFETs. I hope we do not have any damage under this DR MOSFET here. Layer damage, I mean. Let's hope for the best. Now, to replace those two DR MOSFETs, I'm gonna do it on the safe side. So we're gonna remove cap 1, cap 2, and cap 3. I do not wanna cover the caps. Just work safe. We're gonna remove them. 1, 2, and 3, so we can safely work here and here. And Big Buzz just put two 3090s on my bench. That's one of them, right here. If the customer is watching, ticket number 120948. And we also have one here, ticket number 120734. Exactly the same cards. So let's go ahead and measure. Do we still have a partial short? We have a totally blown DR MOSFET which damaged the layers on the board. But we'll see. We should be able to fix it. But for now, I want to measure to see if we still have a partial short. Zoom out. If we measure here, we have almost 0.4, and if we measure here, we also have 0.42. You see, the short is gone. That's what the problem is. Right, so we still have a piece of that DR MOSFET molded on here. We cannot remove it with heat, so we're gonna have to grind it. Pin number 2 from the bottom here should not be making a connection with this pad. It's only the first pin, this one here. But we still have a piece here that we need to remove or grind. All right, so we do not have a connection anymore. Very good. If we check the connection between here and pin 1, we still have it. And we do not have a connection here. Now, one thing I want to find out is what's on pin number 3. 1, 2, 3. So if we check in diode mode from pin number 3 to here, it does not look like pin number 3 is making a connection. I'm checking to ground, no connection. Number 2, no connection. And number 1, we do have 0.4 voltage drop, which is directly connected here. What about pin number 3? No connection. So pin number 3 here does not look like it's making a connection with anything. Let me confirm this by looking at the data sheet. AL00 chip. And AL00 is the AOZ5332QI. It's also similar to the NCP chip that we use instead of the AL00. So if we look here, yeah, it's in the connect. Look at this. Pin number 3 is a no connect. Right here on the far left. The chip is switched on the board, but it's in the connect. Very good. So we grinded the pad. We got rid of the short that we had on pin number 2. Double check and make sure we do not have a short anymore. We do have 0.48 reading. Here to here is okay, but here to here we should not have any reading. Very good. Very nice. Now we are ready to replace the chips. You know what? Let me just clean out the flux. Maybe we can add a bit of solder mask on the bottom. And right now I'm using the NorthridgeFix premium quality UV mask. All the tools that we are using on the bench here, we carry and sell. Just log into NorthridgeFix.com, click on shop, add to cart, checkout, pay, and we almost always ship out same day. We carry everything from this amazing microscope, articulating arm, original Amtech Flux, tweezers, UV mask, UV light, solder wire, hot air station, soldering station, thermal camera, braid wick, low melt solder, like we used in this video to remove those caps, everything. One-stop shop. Log into NorthridgeFix.com, click on shop, add to cart, checkout, pay, and we almost always ship out same day. All items are in stock unless the item is not in stock. I do not want UV mask to be bulging under the chip, so I just want to spread it around. Maybe we can fill this hole right here, this crater. Add a separation between this layer and this pin. And that's all we need to do. This pad connects with this side of the cap, that's no problem. And very nice. So the AL00 is similar to NCP 302150. Especially on EVGA 3090s, sometimes you see AL00 and other times you see NCP 302150. Very nice. We do not need to clean this mask because this side of the cap connects with the big pad inside and with the first pin, no problem. And now let's replace this one. Just look at the quality on this NorthridgeFix microscope. There's nothing that you cannot see. It makes aligning the components so easy. I mean, image quality and visibility is everything in this business. A lot of people want to cheap out on the microscope, and I can tell you one thing. If image quality is not good, you're gonna struggle. Very nice. We transferred that blob over to this resistor. We're done. And tell me that's not better than factory soldering. We are using the NorthridgeFix brush, Amtech wipes, which you can also buy off our site, and 99% isopropyl. You do not have to use 99% isopropyl. 91% is good, 92% is good. Anything over 90% is good. Do not use 70%. Residue of something here. That's cap 1. Let's do cap 2. Low melt solder is not used to solder, but it's used to desolder. It's soft, brittle, and it melts at very low temperatures. Right, and now we have a better than factory connection and a better than factory solder joint. And now all we have to do is measure for a short again, just one last time before we test the card. Make sure we do not have a short. Otherwise that card is gonna smoke again. So we're gonna measure at our 12 volt line, no short, and this is continuous, no short, and this is continuous. Very nice. Go to our PCIe. Very good. I think we are ready to test. And I need to get the housing for the cord in order to plug the power supply. Just a minute. So if you look here, the back plate is connected with the cord. And now we can connect the power supply cables onto that plate. And I think I'm gonna wear my goggles just in case. And I'm gonna put a tiny heatsink over the GPU, the core. Just like this. Power on. Power supply fan is spinning. Yes, yes. Wow, we got it. We got it. Let me shut off the power supply again. Just look at the monitor here. 1, 2, and 3. Heatsink is very hot. Dell logo right here. And now we're gonna see press F1 to continue. And wow, power supply off. Wow. I'm gonna hand the card over to Big Bus to reassemble and test, and I'll be back to finish the video. The cord is working perfectly. We are done. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video.